Okay, in this video we're going to introduce some of the terms that are important to understand when you are dealing with circles. And we're also going to talk about what the definition of a circle is, and we're going to talk about these 4 points, these 4 characteristics I should say: center point, radius, diameter, circumference. And then we're also going to talk about chords, secants, and tangents, what are other types of lines and line segments that go through and deal with circles. Okay, so that's our introduction. Let's get started. So what's the definition of a circle? This is one of those tricky ones. Everyone recognizes a circle when they see it, but to try to define it, it's hard to use. It's hard to define it without using the word circular or circle in it, right? So how would you define circle? I can give you the formal definition, and the formal definition actually uses a term that itself is undefined. You'll remember, like in a previous video, we talked about there are 3 major undefined terms in geometry: point, line, and plane. And we're going to use one of those undefined terms in this definition. So a circle is those points which are equidistant. Let me write this all in here. Which are equidistant, which means equal distance, from a center point on a plane. Now let's unpack this definition just a little bit. Remember, we described a center point as, or just a point rather, as a location in space, a particular location in space. A center point, therefore, is just a particular location on a plane in space. And normally center points, or the center of a circle, are designated this way. You'll see that symbol actually for center points. Now we're going to say all of those points which are the equal distance from that center point. So let's say I move out that distance right here, okay? If I were to take this like pivot and then draw the same distance all the way around, this is exactly what I would be tracing. Alright, so these are all the points that are equidistant from this point on this flat plane. Now that last part is important, because if I took that exact same distance and went straight up, for example, I would still be equidistant from that center point, wouldn't I? But I would also be equidistant here and here and here and down below that point. I would be creating a sphere if I did that. But we're more concerned with what it looks like on a flat plane. Now we've just actually, in our description, we've actually described a couple of the other things that we need to talk about. And one of those is a radius. So the distance from that center point to any point on that traced outer edge is called a radius. And then you designate that by R. Now if I were to take that line segment, right, because this is a segment, it doesn't go on forever, it just goes from point to point, so these are endpoints, and I were to continue on through to the opposite side of the circle, right, I have what's called a diameter, all right, and that's usually designated by the letter D. Now the letter D means that you have, basically the length is 2 radii, right? So you could say the diameter is equal to 2 times R. And you can really start at any point. As long as you go through the center point, all the way out the opposite end, that line segment is called a diameter. And now we get to the last term for this particular part, and that is the actual traced area. All those traced points that are equidistant, that's called a circumference, and that's usually designated by the letter C. Now how do you figure out the distance around that center point or that circumference? The formula for that is 2 pi, which is a particular number, times the radius. So 2 times the radius times pi. Another way of looking at that, 2 times the radius we know is diameter, right? So the diameter would be D times pi. Now pi, remember, can be a number of values. It can be 3.14. It goes on for a number of digits, for infinity actually. It can also be designated as 22/7. So these are all definitions of pi. And it's the ratio between... well, actually, I'm going to say that for a little bit later in a different video. Okay, so those are those four terms. Now let's talk about some more of the lines or line segments that also exist with circles. You'll remember that the diameter went right through the center. Started at one point on the circumference, went all the way through the center, and came out the other end and stopped again on the circumference. There are other kinds of lines, though, that don't go through the center. And one of the important ones is a chord. So let's take a quick look at that. So again, start on the circumference, go all the way through, but do not pass through the center, and stop when you hit the circumference again. That line, or any other line that does not pass through, line segment rather, that does not pass through the center, is called a chord. And there's some relationships that we can do with chords, and we'll talk about that in a different video. Now the secant is related to the chord. So again, let's do it this way. I'll describe it this way. Instead of just doing a line segment, I'm going to do a whole line that does not pass through the center point. Right? And remember that lines extend for infinity? This is actually called a secant. So think of chords as line segments and secants as whole lines. Chords are like a subset, if you want, of a secant. All right. Now the last term, which is really kind of interesting and important, is called a tangent. Now just pick any point on the circumference, right? A tangent is the line that only touches the circumference once. So let me just do this. And again, usually it can be a line segment, it can also be a line. Let's just make this one a line. And one of the really interesting characteristics of a tangent is that it always forms a perpendicular or a 90-degree angle with the radius at that point. So that was the radius at that particular point where it touches. By the way, this point where it touches is called the point of tangency. And again, the line that, or the angle that it creates is always a 90-degree angle with the radius at that point of tangency. That actually makes it a very valuable line to understand the relationships with. Okay, so just again real briefly again, the characteristics that we're interested in are the definition, all the points equidistant from the center point. The radius is the distance between the center point and any point on the circumference. The diameter is a line segment that goes from one end on the circumference, one point on the circumference through the center point, and then all the way out the other end, opposite end, diameter. Circumference are all those, the circular outside edge, all those points, the relationship there. Chords, secants, and tangents. Chords are line segments that do not go through the center point. Secants are lines that go through the circle but not through the center point, and then it goes outside. And tangents are lines that touch the circle only once, and they form 90-degree angles. Okay, I hope that was all helpful.